That to you.
Okay, good morning to those on the West Coast and good afternoon to the rest of you. Let me start by saying, apologize for my camera. I, for some reason, am not able to get it to work. I've even gone out of the meeting and back in, and it's just not stable today. So I'm going to figure I'd rather leave you with my mugshot than just a black screen. So um, I'm going to be initiating the talk today on P100 Chapter 4, covering the subjects of structural and civil engineering. My name is Bill Earl. I am the program manager for structural engineering for GSA. Henny is the program manager for civil engineering, and he'll be talking to you shortly. Currently, the way Chapter 4 is organized, the early sections 1 through 5, are covering structural engineering, and sections 4.6 through 4.9 cover civil engineering. It used to be a little bit more concentrated. Last cycle, the civil engineering was just a brand new section at that time, and Henny's done a great job expanding that on this particular version. Before I get started into talking about the changes made to Chapter 4 on the structural engineering side, I just want to give credit to the technical committee for structural engineering that assist me in making these updates. You can see we have a really broad GSA regional scope here across the country in terms of participation, and I just want to make sure everyone knows who actually puts the work in. The changes we made in this cycle were not what I'd consider to be major, but they can be grouped into about 3 different kinds of categories. The first category is real simple changes, just to make the document more clear, more readable. The second category was some new documents, some new topics that were added to the chapter on structural engineering, just to probably in response mostly to questions that had come up since the last cycle. And then the third category was some changes we made to the performance tier tables, and I'll cover each of those separately. On the general section, as I mentioned before, we really just tried to improve on the readability of this portion of the chapter. We looked where we could to use plain language. Of course, we updated references to make sure that we were looking at the latest technical references that we prescribed to. We also tried to make the language a little more consistent. So if you were reading one section, you pretty much, next time you read another section, it kind of gives it layout in the same format. And then we made sure that the ordering of the topics were in conformance with the performance tables that are start at the beginning of the chapter. Pretty simple stuff, nothing major. The new topics that we added, again, these were in response to questions that had come up since the last cycle, or they were from feedback we received from industry participation. And none of them are covered in great detail. Since they're new topics, I don't like to add a new topic and include an entire chapter on it. I like to bring the topic in, give it a general sense of where we're headed, allow it to evolve over time. So each of these sections will probably expand in the next cycle, but for the time being, they are mainly there to address the questions that had come up and make sure that we're heading in the right direction. And these basically include what you see there in the list. Some of the things that have come up, like the special durability requirements, that has always been a problem with some of our facilities that have corrosion problems because they're located near salty areas, near ocean beaches and such. Forced entry is a new topic that has become a really big concern, and we have, over the last 2 years, embarked on a nationwide courthouse hardening program. We've also encountered hazardous materials being stored in our buildings that initially started happening happening during the COVID time period, and in aftermath, we've developed some guidance to address all of these things. And then the third area where I wouldn't call it a major change, but it's a little more substantial than the first two, is we've aligned the performance tiers to work along the same lines as the IBC risk categories. And of course, the risk categories really originate in the ASCE 7 document for design loads. But what we tried to do consistently is for risk category 1 and 2 structures, which really represent your basic building in the real estate market, we tried to make that our baseline across the board for structural, non-structural, seismic, and wind as well. And then for tiers 1 and tier 2, we went from risk category 1 and 2 to risk category 3. And then for tier 2, we went up to risk category 4. And just for those that aren't familiar with that, risk category 4 are structures that are considered to be essential structures that need to be available immediately after an event, such as a large earthquake or whatever. And risk category 3 structures are mainly structures that have a large population in the building, where you're concerned about if there was a problem with the building, could there be a significant loss of life or injury levels. And then I should note that we actually always had a fairly good alignment with our ISC tiers. Our baseline has always been ISC level 1 and 2, so this really hasn't changed. But again, ISC levels 1 or 2 represent your typical commercial buildings in the real estate market. Tier 1 coming up to ISC level 3, where you start to engage in some more security requirements, more in line with your average small federal or medium-sized federal building or federal facility. And then our tier 2 steps up to FSL level 4. And that's where you have major facilities like courthouses and large federal buildings. And then we have a tier 3 for FSL 5, which is very rare, but very highly important buildings and campuses. So that had not changed, but it was nice to bring the other ones, the other performance categories and tiers in alignment with the way we did security in the past. So that's pretty much the rip of what the changes we made on the structural engineering side. And so with that, I'm going to turn it over to Henny.
Thank you, Bill. I'm Henny Ramawi. I'm a civil engineer. I happen also to be a team member with Bill under the Center of Engineering. So I've been with GSA just shy of 2 years, and coming on board, I took the program management of the civil engineer component here in the P100. We have some minor updates with a robust change to the flood mitigation sections, and hopefully down the line, as we continue with the updates with the P100, we'll aspire to have a standalone civil section, but we're not there yet, but we hope to be. Just wanted to share some of the recent news here. Happened earlier this month. The P100 Steering Committee voted and approved the creation of Civil Engineer Technical Committee. So this committee will be responsible in reviewing any of the waivers that come for the civil engineering section. The group is in the works right now in terms of formation, and we're going to look to have about 5 to 6 members, and have the members at least have a coverage through the zone A through C. So at least one member from each zone. So that's an ongoing development. Okay, so some of the changes we had under civil engineering, minor for the most, except for section 4.6 and 4.7, where we had replaced the flood mitigation section with a flood resistance design section that also includes a robust implementation of FFR requirement, which is the Federal Flood Risk Management Standard, and also takes the flood requirements that were scattered through different sections, such as mechanical, electrical, and building enclosure, and just put it in one location, and it's going to be sitting under the civil engineering section. Some of the storm and drainage requirements, my updates added. We moved the section on from under utility. We added it under the drainage for stormwater, and we added water recycling requirement and linked that to chapter 1 and 2. And it also updated some of the requirements for coal tar sealant to be in line with chapter 2, I believe, in P100. And then also we moved low embodied carbon concrete to chapter 1, along with environmentally preferable asphalt to chapter 1 as well. So some terminologies there that you're gonna see added as part of the performance table for flood resistant design. Design flood elevation, DFE, that's a term that's going to be in line with what's been used under ASCE 24. You also see flood design class, which it's a category of buildings based on the criticality that's also going to fall in line with ASCE 24. Risk category, which Bill mentioned earlier for ASCE 7, that's also been used as part of the flood mitigation. And then also the term BFE, base flood elevation, which for everybody, if you're not aware already, that's the 100-year flood elevation, which also equates to the 1% annual flood chance elevation. So different terms, same meaning. The 500-year, just want to note that equates to the 0.2%. So that's a different terminology there. Also, you'll see the climate informed size approach term, CISA, not to be confused with our sister agency, which happens to be the Cybersecurity Infrastructure Security Agency. I know they use the same acronym, but in our floodplain world, the CISA is related to a particular approach, which include forwards-looking climate information that would give us an assessment on how high the floodwaters will rise with a certain period of time. And then FFRMS, the Federal Flood Risk Management Standard, that being reinstated with the recent issuance of the Floodplain Management Desk Guide, Order PBS 1095.8A, that was issued November of last year. So that term also is being used here, and some of the design centers also been updated to that. And then obviously the last one, last but not least, is the National Flood Insurance Program, NFIP. You'll hear that a lot. Just want to make sure people understand what the NFIP stands for, which is the flood insurance program that many of the localities that we build and construct, which we are neighbors, have rules and regulations that follow the NFIP. And us coming into the floodplain, and we have to build adjacent to that, we also have to be able to adhere to those standards as well to make sure that they don't have any adverse impact. So want to highlight here section 1.3.9, the facilities definitions. This was mentioned earlier in Lance's presentation as part critical action or non-critical action. This is a designation that's essential to have it established early on in the project, preferably during feasibility stage. It does have cost ramification, as you will see in the tables and the next slides. Non-critical action would have a lower standard design. Critical action would have a higher standard design. And the recent issuance of the Floodplain Management Desk Guide has guidance on how to go about to attain that designation. It would require to have the customer agency sign off on a letter letting us know that how they want to designate their facility. And if it's something that GSA owns and operates and occupies, then it would fall on us, GSA, to make that determination internally, which is fall on the regional level. So section 4.6, we included the performance table here, 4.6.1. That's a new numbering. Performance had, and you'll see the also building enclosure you had on top. So this table is taking into account different categories, being one is the building enclosure and site, and then you'll see the mechanical and you'll see the electrical and generator in the following slide. So the first slide here, we merged the site, civil, and the building enclosure under one category, and they both shared the same design standards. Under the performance tiers, you'll see two columns, the non-critical action that highlights the design requirement based on the baseline 1 through tier 2. And then you'll see the critical action on the right column, which is the higher tier risk level to design 2. And also you'll see that going through baseline all the way down to tier 2. The DFE term is being used here, and again, to be in line with ASCE 24. For example, for non-critical action, we're looking at the baseline design flood elevation to be the base flood elevation, which is 100 year plus 2 feet. And then we would have a flood design class set at 2 with the rest category set at 1 and 2. These information that you see here is related to application of ASCE 24 and the risk category to be applied with ASCE 7. And they increase in level standard as you go to the right, and it increases as you go down. And some of the highlights there you see the added elevation buffer. The BFE plus 2 feet or the BFE plus 3 feet also relates to the freeboard value approach that the Epipharma applies. So we are in line with that, and the increases in that buffer adds with the tier level. So if you go down to tier 1, tier 2, and project requires to have an added a freeboard, the tiers then can be engaged, with the tier 2 being open-ended for a higher level. For the measurements and verifications down to construction verifications, we did also update those sections. We want to emphasize the need to document the applicable DFE and the flood design standards in the narrative, design narrative, the plans, the specifications, and any emergency action plans if one's being developed for the specific project. We also want to see a section dedicated in design narrative that has to do with floodplain. So all the related flood resistance design be added in one section so we can track, and also any components that need to be added for emergency action plans. For example, if you have any dry or wet proofing that needs to be engaged, that information that's added in the design of it can be captured and carried in the emergency action plan, wherever is one being developed. We also added references for the flood study and mapping, being that if, whatever sources you would have external, or if you have one done internally, we'll make sure that's, being tracked. And also the listing of the relevant ASCE requirements. And also we added the the new standard, which is American National Standard for Flood Mitigation Equipment, 2510, and that's specifically related for flood resistant equipment, being barriers, flood barriers, mitigation valves, pumps, etc., and then make sure that they're certified to that standard. So I'm going to the next slide here. Let's see. So the next slide related to the mechanical. So you can see here part of the 2022 section. It was one line. There was no table. It was under section 5.3. We took that and added it into performance table. And we also created a level for critical action. So you'll see under critical action is PFE plus 5. Under critical action, it goes up to 500 year elevation plus 5. And this is in line with the electrical components as well. And similarly as the previous table, as you go to the right, it increases, and as you go down the tiers, it increases as well based on risk requirement. The electrical and generator system got merged together. Previously under 2022, there were two different sections. Again, the components that were noted as part of that narrative get captured here in the performance table. and they follow the, again, the non-critical action designation versus critical action designation. Under 4.71, which is the performance attributes, we want to make sure to note some of the changes here, being that we have listed sources, available sources for floodplain information, referring to the floodplain management desk guide. In there, there's a list of applicable sources that you can see, being that FEMA websites have flood data, localities, or other agencies that might have information you can share. In the event there's no available floodplain data, we will look for the project team to conduct a hydrologic and hydraulic analysis or flood study to determine and set the design flood elevation. Or in an event, if the data that we have, let's say from FEMA, is more than 15 years old, then you should be considering getting a new study completed. Now, when I say 15 years old, it's not related to the date listed on a map. It's related to the actual analysis for the floodplain that's for the riverine or the coastal. So FEMA has a habit of taking old maps and recycling them, and updated colors, but they still keep the core study from the 1980s, for example, the 70s from their initial. So we want to make sure that we are studying the streams or the water bodies that are impacting our side relevant to up to our date now, not taking something from 1980s and running with it. And a lot of times what you're going to see out there also, FEMA mapping will include elevations for the 100-year elevation, but it will not include the 500-year elevation. So if the 100-year elevation is deemed available and it's current, we would allow for the 500-year elevation to be determined at BFE plus 3 feet. So that's 100-year plus 3 feet. So that's something new, a new math in there to add in. Instead of having to do analysis to come up with the 500, just use simple equation here, as long as the 100-year is up to date. The CISA elevation, particularly for coastal areas, the science is in place to be able to use a CISA elevation in lieu of a freeboard value approach. We're going to allow for that to be substituted for the baseline DFE for the building enclosure and the site only. The job aid, the performance job aid, is a good component to look into with recommendations how to come up with that elevation. So I encourage you to look into that. The application ASCE 24, ASCE 7 continues to be required. We just want to make sure that when those guidance are being looked to, that the flood hazard area designation be established by the team. We're not necessarily setting them up right now as part of the attributes of the performance, because it's going to be unique to the location of the project. So you could be close to a coastal area, so then that sets you under a coastal high hazard. Could set you under coastal high hazard location, or you could be inland riverine, and it would be as simple as flood hazard. So that's something, just keep track of that as you set where your locations, because that sets your design guidance under ASCE 24. Again, when we emphasize dry and wet proofing as being a component of flood resistance, dry proofing could involve raising the site completely, so you are at 100 plus 2 or 100 plus 3 in terms of ground elevation. Wet proofing could be not raising the site, but you would have the ground floor lower than 100 plus 2 or 100 plus 3, and your first floor elevation is up high. So then that ground floor ends up being in some locations as open space, or it could be a parking garage. So just two different flooding protocols. Just want to make sure you're aware of that and have those different approaches clear. Products for dry proofing, particularly with barriers and valves and pumps, like I said, should meet ANSI FM 2510 standard, and that's the standard used for flood protection. Also, I want to emphasize that we want to see no adverse impact to any development in the floodplain. So yes, we are federal land. It's our site. We build, we fill, but we still impact neighbors adjacent to us, which happen to be localities, states. And we want to make sure that whatever we build, whatever we fill in the floodplain, does not impact sites adjacent to us that are outside of our control. And we could require that should the team show us pre and post modeling analysis to demonstrate that, and state and local official could require that as well. So that's something I want to emphasize: no adverse impact. You fill in the floodplain, you got to make sure that floodplain does not impact somebody next door. So that's something to keep track of as well. And again, as I mentioned earlier, flood resistance documentation, we want to make sure that that narrative is being captured in a clear section, and then the plans and specification are updated and tracked accordingly to show any flood proofing and flood control. Under site grading and drainage, we updated the site drainage system. We moved the section from 4.82 under 4.81. And we also clarified that location of drainage systems, drainage pipes specifically, need to be an unpaved area to the extent possible. Now, I know you have to set your inlets, you have to catch basins, they might have to cross the pavement. We just want to make sure clear to have those pipes placed in unpaved area to the extent possible. We also emphasize that we want to comply with SF 438. That's the law, as Brendan mentioned earlier in his presentation, but also we want to make sure that we are in compliance with local stormwater management requirement. State, county, localities might have stormwater management requirement that could be more restrictive than SF 438, and we want to make sure we are in compliance with that as well, because that goes into line with the NIA, non-adverse impact, to localities and the neighbors. We also wanted to see a performance analysis done for the proposed drainage. The drainage design, the way it is noted in the P100, is to be designed to a minimum 25-year storm event. So your designers will set that pipe in place, set the inlet locations, the spacing and such, but we want to see how the site behaves under 100-year and 500-year flood conditions to make sure that we're not adversely impacting our buildings. So that's could be an iterative process, but something that needs to be tracked to be aware of, because that's a local flooding that could be overlooked, and we want to make sure our proposed design does not end up making things worse for us. So that's a capture in there, just to note of that. Also, we noted that inlet and catch basins to include bicycle safe rates. Most localities and DOTs would have that generally, but we want to make sure that, particularly for areas that's traveled a lot, to make sure to have those grates and inlets bicycle safe in place. We noted some minimum requirements for flow velocities for the drainage pipes, being 2 feet per second as an absolute minimum, ideally at 3 feet per second. That's for maintaining cleansing for the pipe. That helps long-term maintenance and operation crews to to go in there, flushing and all that, minimal flushing, because we set the pipes at a certain slope. And also the maximum velocity to be set at 10 feet per second for the pipe. This is to maintain the longevity of the pipe from being eroded, and also to have a manageable outlet protection down the line. So instead of having concrete base with core with steel core, you can rely on riprap outlet protection. So 10 is the max. And again, these are some localities and DOTs are good at having those as part of their design guidance, which the P100 differs, and a lot of times when it comes to utilities, to the local requirements. But we just want to make sure we're consistent across the nation. Minor updates here: the site utilities. We added the water recycling requirement. We noted with trying to meet the local and state requirements there, and references to Chapter 1 and Chapter 2. And as for pavements, addition of non-coal tar sealant requirement, which wasn't in the P100. We just made sure that we're in line with Chapter 2. That's about it. Any questions? So I think I see.
Yeah, Henny, there's one question in the Q&A.
On the P100 500 flood category, how is climate change affecting this? Are the flood design standards changing constantly? So if I go back to the categories that I had before, let me get that table on for you, Ron, so you can see. So as part of our design, let's say for building enclosure and site, we are looking at base flood elevation being the 100-year, and we're adding 2 feet. So that's your freeboard. That freeboard value is supposed to account for future flood rise. That could change down the line as we see how the climate is morphing in the next 50 years. Right now, that's a freeboard value. That elevation can be substituted with the CISA approach, particularly for coastal areas now. And that is more science driven, and that can have more of a dynamic elevation depending where you are in the country. The inland for the CISA approach is not there yet. So hopefully when that comes, we might lean on that more, because that's going to be more precise information that we know based on climate change. But right now we are using more of the freeboard value approach as it relates to the FFRMS requirements, which is including the buffers. In this case, 2 or 3 feet. And if we move to the next sections is 5 feet for the for 100, or 5 feet for the 500. Any other questions? And again, I encourage you all to look at the training we had for the new floodplain desk guide we conducted early in this year as part of the A&E series. You'll see Brendan and I talking on the implementation of that guidance. So feel free to check it out.